Hello guys, and welcome to this second episode of our series of events here live on Twitch. So today we are gonna see another game. That's the main topic of today. We're gonna see the second game integrated on our dueling AI arena. So as I said in the previous episode, whenever you have questions of willing to interact, please write in the chat. Hello Mattia, it's really good to see you. Oh, great to have you here. So anyone who has any comment, any question, please use the chat. We are here for answer your maybe your interest, your questions about how the things work, and maybe also things you are curious about. So as I said, this is the second episode, and in the first one we introduced basically what DIAMBRA is, our background, mainly in terms of academic and professional experience. That was, I believe it was useful to, let's say, let you know what is our technical knowledge, our skills, the things that we had to manage in order to build this type of initiative. So in case you missed the first episode, please you can find it, the full length episode. You can find it on YouTube. Actually, it's I can share the link here with you. Actually, there is a timer in the chat that would show you the link to the YouTube page. Otherwise, you can go to the website. The one that you are seeing here in the screen, and in the website, just scrolling down a little bit, you find our main three, let's say, platforms in which we have our profiles. And so on the YouTube page, you can find the entire playlist of all the episodes. So for now, of course, the intro trailer, and then the first pilot episode. So everything is in there. Nevertheless, today we are gonna let's say recap very briefly a few things that will be useful to follow this new event, because we will be again taking a look at how the agent behaves. So we need to be a little bit familiar with the layout, with what is presented on screen when the agent or the human is playing, because those those aspects are really important in order to understand what is happening behind the scenes. And so it's good to have a clear catch of what is happening. So now one important thing is, I wanted to stress a little bit, maybe it wasn't perfectly clear last time. I will go now I will go with a very short presentation, few images actually. So first thing to remember and to keep in mind is that DIAMBRA is made, let's say, it covers three modes. It covers three main modes, game modes, and those three modes are listed here. So basically on hi Alessandro, hi, great to have you here. Hello Curaro, thank you for your message. It's great to have you here. So three game modes. The first one on the left, you see it's AI versus COM. That's the standard mode when you have to implement the first time reinforcement learning. So you basically build an agent, a program, an algorithm, and then you make it first face the COM opponent, meaning the standard game run, let's say. In the middle, you have the AI versus AI mode. In that case, this is what we are gonna use to make different agents compete one against the other. So this is the mode that we will be using in our tournaments. So when we will have all agents trained by people around the world competing in this tournament, we are gonna use this one, because this is the mode that allows you to make two different algorithms compete on the same field, one against the other. Finally, on the right, we have the third game mode, that is also in this case really fun. And hello Mao. Oh, okay, this is nice. Maybe later in this adventure we will be able to share with you our shirts, so that's pretty cool. We have plans for that. No problem, thank you. This is the reason why we have the chat here. Anyway, the third mode, the one on the right, is the mode that allows you to use your AI agent to compete against a human player. So this is the mode where you will see an RL algorithm competing against a human. So that's the third one. Actually, to be completely clear, there are two additional modes, but they are mainly used internally, and you will see how in the next episodes. These additional two modes are those that basically represent a human competing against a computer and a human competing against another human. So I can show you that those modes are already there. In fact, you see those modes are always listed in the bottom right corner. Right now you see we have a badge that shows that we are discussing. We are in the discussion phase. This will change once we will be playing and running the game. And so I will shift from discussion to, for example, AI versus com. Okay, then in a later stage I will shift to this one, human versus com. Okay, this is another mode that we have, and so yes, there are also another one, humans versus humans. So this completes our all our 5 different modes that are in place. And now, yes, you will see them listed in this bottom right corner. So getting back to where we were, yes, this basically completes the recap about different modes, how they are displayed on screen. But another good thing to recap is the reinforcement learning setting. You know, this is how the reinforcement learning is schematized in this context, in the context of DIAMBRA. So really quickly, we have an agent, you see represented on the left. We have an environment, and they interact. How? The agent, of course, as a human does, sends actions through the gamepad to the environment. Now the environment reacts to these actions and updates its state, that is provided back in response to the agent on one side. The environment also provides the agent with a reward. The reward is a measure of how the agent is behaving, if it is doing good or if it is doing bad. Now, we can say that basically the reward needs to be explicitly provided to the agent, because that's the so-called learning signal. It's the signal that the algorithm uses in order to improve the way it is playing in this case. Now, it is also something that we as humans use. In fact, every time that in a fighting game you suffer an attack, you know that you have done something wrong. And so in some sense the reward is something that we as humans also use. Yes, this is more or less the basic idea of how the reinforcement learning settings is represented in DIAMBRA. Now, moving to another important aspect is the Windows layout that you will see during our play here. So This is the layout you will be familiar with, and you see on the left we have the complete reinforcement learning scheme. On the right we have on the top of the right column we have the real game itself, showing the current situation. In the bottom part you have a rolling log showing you the actions. In this case, actions sent by the agent to the environment. So here you will see the actions, so both move and attack actions written in text, while in the left window you will see the same actions displayed overimposed on the gamepad itself. You will also see a percentage of the actions confidence updating each frame. Now, in our case, when we will be using a random agent, these probabilities will be fixed, because we will be choosing between a given set of move actions and a given set of attack actions randomly. So these numbers will be fixed. This will not be the case when we will be using a reinforcement learning algorithm. So yes, you will see that in the next sessions. It will be fun, I promise. Now, the state, really quickly, is composed by a set of frames representing the game state, so what you can see, and this is basically images. Is composed by images. Then you have additional info. Additional information has the health of AI and COM opponent, the side of them, so if they are on the left, if they are on the right of the screen, the name of the character, and the previous actions. In this case, previous actions taken by the AI agent. These are useful because if you do want to perform a combo, if you want the agent to understand and being able to reproduce a combo, you need to give him information about what was the previous move, and so in order to put them in the right order. Yeah. Now, the other part, the reward, is composed mainly by two elements: the immediate reward and the cumulative reward. So, as I already explained in the previous episode, this is a zero-sum game, and so the value of the cumulative reward will be basically the opposite for the computer with respect to the agent. We have a first questions. Alessandro is asking, well, if I understand your question correctly, the agent, in order to defend itself or himself, should learn to predict what will be next frame move by the opponent by taking a look at the picture. So basically analyzing how the opposing character is behaving, the way it is moving, and it has to understand that it is going to hit in some way. And so in this regard, it needs to understand that the opponent is gonna do that specific move and so act appropriately. In some of these games, for example in the first one, the other life, there is also a button dedicated to counter moves, and so if you are aware that your opponent is gonna hit you, now you can use that counter attack button, and that will help you avoiding losing health. Not sure if I got your question right, Ale, and if the answer was clear enough. Hello, the Rockerman. Okay, thank you Ale, for your feedback. Okay, So yes, this is more or less what you are gonna see during the usage of the platform, and it basically allows you to understand what is happening behind the scenes. Now, in this case, you can see you have on the left the AI agent, on the right the COM opponent. So in the case that that you have AI versus AI agent playing one against the other, you will have another AI agent on the right, and so another gamepad here with other actions that the agent is choosing, an additional row of previous action referring to AI agent on the left, on the right, sorry, so player 2 position. And so in some sense it's slightly different, but it doesn't change a lot in terms of, let's say, the meaning of everything. Now, this is what I wanted to recap, because it's useful to take a look at when we will be using our agents. Now, this is a specific representation of what is happening. It's a part of the entire window layout. Now, this, I wanted to share with you this nice picture, because I wanted to, let's say, share the history behind the name. I was reasoning about how to call this initiative. I've been working on it for quite a long time. And so it has always been clear to me that the main idea was creating an environment where, you know, very similar to the idea of Robot Wars, you know, that TV series where people were building robots and then making them fighting one against the other. Yeah, I wanted to create something similar for AI agents. So the idea in my mind was to create like a dueling AI arena. That is basically the name, the payoff of DIAMBRA. And in this sense, I asked myself, okay, it would be really nice to and find a good name representing an important duel. So I started looking in the history of about finding, you know, important as well as famous, but also particular duels. Of course, there are quite a lot of curious things about duels, like the one about Galois, the famous mathematicians. You know, there are a lot of duels in history, but one that captured my attention was the one that is depicted in this image. It's basically the only duel carried out by women in history. I mean, at least a legendary one. And you see here the two. One woman is called Isabella de Carazzi. The other one is called DIAMBRA of Pottinella. So you can understand that basically I was trying to have a name, and this. Women, they were fighting for the love of a man, and so it was, you know, kind of really cool idea behind this legendary duel. And so I decided that DIAMBRA was the name I was looking for. And by the way, it is pronounced, I mean, I'm pronouncing it DIAMBRA because DIAMBRA was an Italian woman, and so even if sometimes I happen to call it DIAMBRA because you know the type of name pronounced in English, but that's the history behind the name. Now, hi Filippo. Hey, it's great to have you. It's great to have you here. Glad you joined us. If you have any questions, please don't hesitate to ask. Now, another aspect that I want to share with you is reasons and why I find reinforcement learning so interesting. and in particular the application of reinforcement learning in video games. Actually, there is more than one reason. There are different reasons why I believe they are really nice perspectives in applying reinforcement learning in video games. And I will start the main one, but I believe that the main one has to deal with a very, let's say, important dualism in video games. And I will use two images to explain this idea. Let's say I have. So this one, is the first image I would like to share with you. It's a single-player game moment where you are playing your game, you are interacting with the environment somehow, you are trying to reach a target, an objective. And basically you are living a story, you know, you're living a story in which you're immersed, and you can have something to say about it. I mean, you have to achieve some accomplishments, but still the history is there, and sooner or later you learn how to trick your opponent, your computer opponent. So it's something like that. To me, is more similar to like watching an interactive movie in which you can do a few things, but sooner or later you are gonna finish that game, and that's it. On the contrary, when you are playing in multiplayer, yeah, that's not the case. I mean, if you are not good, you may never win a match. And so, in addition, the experience is always changing. It's always changing because your opponents may understand and react to the way you are playing. They may invent new tactics, new strategies, and that's not the case when you play in single player. This is one of the main aspects in which I believe that reinforcement learning will play a major role. In fact, in theory, it is really possible to create autonomous agents against you can play and against which you can play, and if trained properly, those agents can be hardly distinguishable with respect to humans. You know, so these technologies can allow you to enjoying in the very same way you enjoy multiplayer, also in a single player, or maybe providing a better experiences in playing in multiplayers. So this is one of the main reasons why reinforcement learning can be a really game changer in terms of video games development. So now this completes the introduction, and we can move to the reveal of the second game we interface it. So let's stop this one and let's shift to the coding set. Now, okay, so in order to show you the next interfaced game, I would like first to let you know that what you will be seeing on screen are those additional information that I already told you will be used by the agent in order to be trained. So those are basically extracted using RAM values, and they would represent, for example, the health as well as player position and so on. So now I'm gonna execute a game emulation of this new game, and we will see which one will be. Okay, so basically, yes, of course, it is saying to me, I don't know any NumPy, what is that? Yes, it's because I didn't activate the virtual environment. Now it will be different now. And so you see, we are starting the game, and as you will see, it's a Street Fighter Third Strike. So we are gonna use this one as third game interfaced. Let me choose an opponent that is quite, you know, famous, for example this one, and I will just show you a few let's say moments of gaming here, because I will be using it through the keyboard. But you see on the screen, you will be seeing the rolling log showing you the health of both players, position of both players. These values are changing because we are reading them in real time from RAM, and so those are the additional information that we use together with the frame. So basically we are using those things together with pixels information. I tried to interface everything in a way in which it basically resembles what a human can use and see when fighting in this type of games, and so nothing else is read from RAM, and so just these basic things. You see, I'm not so good at this game, I must say. You will be seeing me playing later. So as you can see, we have access to those values that are changing in real time, and maybe an interesting, you see, oh, okay, I got this one. One interesting aspect is noting that the health has a value, a starting value. For this case, I believe it was 160. Let me check at the beginning. Yes, it's 160. You see. Now this is the basic values, the raw values provided by the environment. We will be processing them before passing them to the algorithm. In particular, we will be using, as I said, for the other game interfaced, we will be using normalized reward, and so since the reward is based on health, that's it. We will be using a reward of maximum 2. So the health bar will be maximum value of 2 for each round. This means that if you win both rounds with a perfect, you will have a total reward of 4. Now, in the case of Street Fighter, the number of stages to complete the game is 10. This means that for a perfect game, the total reward will be 40. This is the maximum cumulative reward for a perfect agent. Another important aspect we have to evaluate for this game, let me try to hide the panel. Let me see if it is working, because sometimes it doesn't work. Anyway, the other important thing of the environment is how many actions you can send to the environment. So in that case, we do have to take into account how many attack actions we have, because move actions are of course standard, and I can show you, because you have up, right, left and down, and all the let's say middle positions between them. I can share with you a demonstration of a live demonstration of how the controller is used for this new game. So let me see. Now we are using this gamepad. Yes, this is not what we will be. Oh, I'm sorry about that. Let's see. Okay, so basically, you see we have these 4 moves. Of course, the intermediate moves, and then we have the attack move. We have 6 different buttons for Street Fighter, 6 different actions. But we do also have combinations. In particular, we have 3 combinations. So basically the total amount of actions, of attack actions, is 6 plus 3. So 9 actions for the attack plus 8 actions for move, and then there is the no action move, of course, when you do nothing. So this is the total number of actions that defines the action space. As I already explained in the other game, this means that you can treat this action space in terms of 2 different sets, one representing the moves and the other one representing actions. Or, and in this case you do have a one set with 9 possibilities and the other set with 10 possibilities, because you have 6 buttons plus 3 combinations. It adds up to 9 plus 1 no action, 10. So in the other configuration, when you consider every action to be a part of one single set, you have 8 moves, 9 attack, and it adds up to 17 plus 1 no action, and it is 18 discrete action space. We will be using a random agent counting only discrete set, so just one set of actions, and we will not use a buttons combination, so only 6 attack actions. Now it will be clearer pretty soon. Now number of characters. In this case, for this game, the number of characters is 20. We saw Dead or Alive, the number of characters was 11. In this case, we do have 20 different characters. Okay, so it's time to see how the random agent behaves. Okay, so let's move to this one. Oh, nice, Ale, you are let's say touching a particular subject. In effect, the fact that first of all, Street Fighter has 6 different buttons describing actions. With respect to Doa, that has only three actions: hold, punch, and kick. This for sure is something that makes it more complex in terms of the dimensions, because you see you are using more possibilities, so it's harder to understand which for the algorithm it's harder to understand which is the best action. So but I have another observation that in some sense it has to be taken into account when evaluating the difficulty of the game. Let me just send this script. So, but let me check one thing. So here we are. Let's say I will use 5 episodes. So we will be evaluating in 5 episodes the average reward of the random agent. Let me execute that. Okay, so let's start with this one. We will be seeing in a few seconds the entire setup. First of all, the game screen that is booting. And you see here we are reporting that the action space is discrete and we have no buttons combination. So this one will be a representation of the environment. It will be, now it's a frozen screen, but it will be updated pretty soon. And now the game is choosing the default character it want to use, that is Ryu, I believe. We will see. Yes, it's Ryu playing on the P1 side. So the system is choosing everything by itself, so it's pre-scripted. Now we will be seeing a refreshed screen on the left once the thing will start. You see now? Okay, so we basically are seeing in the first episode of 5, and the running log shows you what is doing Ryu, so the action that Ryu is choosing. And in this case, it is also, of course, represented on this gamepad. And in the meantime, we see the value of health of both players and the reward, both immediate and cumulative. The other thing I wanted to mention, continuing the answer to Ale, is that, of course, if considering the action space, Street Fighter is more difficult. But there is one thing to take into account about Dead or Alive, and is the fact that it is, let's say, more or less is a 3D environment. It's not a 3D, but you know, it has the three-dimensional possibility. So you can move in the orthogonal direction with respect to the screen plane, and this it's a tricky thing to be treated by a neural net. In particular, by a neural net that needs to process the pixels. On the contrary, here Street Fighter, you see it's basically a two-dimensional playground. So in some way, basically it levels up. So now we are seeing Ryu fighting against Makoto here, and as you can see, Ryu is performing random actions. It can be pretty easy to understand, I mean, to find out that is a random agent. As you can see, it is basically trying to hit the character even when it is very far, and that's clearly something that is done randomly. Now, this is why are we running a random agent? Well, the reason is it's a standard baseline to compare with an RL agent. Why? Because the RL agent starts by playing randomly. And so you see, by the way, in this case, we obtained a cumulative reward for Ryu equals to minus 1.44. Okay, this was the cumulative reward for the random agent. Now, this is the value, actually the average of all collected values is the reference value that needs to be compared with the AI agent value. Because if the AI agent is able to obtain, in a statistically meaningful sense, a higher reward, then that's the demonstration of the fact that that agent has learned in some sense has learned to play, at least it started to learn how to play. So this is the reason why it's important to have a random agent. Now we will take a look at this episode 2. I hope it won't last too long. One thing that I already mentioned in previous episode, it's useful to keep in mind that reward is the real element to take into account when you want to understand if your agent was able to learn how to play. And it's not, I mean, the stage you are able to reach with your agent is of course one important thing, but is not so precise as the reward. In fact, it is possible that an agent is able to reach, let's say, the final stage, but still getting a worse reward with respect to an agent that is maybe able to only reach the previous one. So the reward is our real target that we want to maximize. We are trying, when we are training our agent, we are trying to maximize that specific value. Okay, so it is important to keep in mind that, because when you will be watching the trained RL agent, Of course, the stage at which it will arrive is important, but the main value to evaluate, to understand if it has learned something, is the specific reward it is able to achieve. Okay, so we are still on episode 2. It may take quite a lot of time to complete the entire run of every single episode of the series of 5. Maybe in the meantime that the game goes, if you have questions, this can be the perfect time to ask them in the chat. We will see how long this will be also in this game. Okay, Marco. Oh, Marco, this is a great question. These are really great questions. Now, it depends on what you want to do. If you want to train an agent, you may have let's say, the goal of training something that is able to play with every character in the game. Okay, so in that case, you need to build an agent that takes also into account, has a signal, which is the character that he is using. Now, okay, before continuing, in this case, in episode 2, we got a reward of 0.26. Remember that the maximum value is 40, okay? Now, Marco, getting back to your question. Now, you can choose that. So I want to train an agent able to play with every character in the game. In that case, you do have to make it experiment with every character available, meaning that the thing that you do in one character must be repeated for every character in the game. So if it takes like let's say 1 week to train an agent with Ryu, and you want to do the same thing with every character, then you have to take into account maybe it will cost you around 20 weeks, since you will have to do the same thing for all the 20 characters. That's not completely true, meaning that maybe you can reuse something that has already been trained with Ryu on the other characters. Okay. In our cases, what I'm gonna show you, our trained agent are trained on a specific character. Okay, so they will be using one character and only one. Another question by Curaro. Oh, come on, this is a great one. This is super interesting. Now the basic idea, I mean, let's say in some sense the most interesting idea of RL is to start from a random agent, because it means that you are not embedding in any way your knowledge on the system. So there is no human intervention, everything starts from scratch, and it just behaves randomly and starts from there and then goes on. There are other techniques that help you speed up learning. One of them is, for example, imitation, the so-called imitation learning. What's that? Imitation learning is basically a technique that allows you to use, for example, human examples of good behavior to create a baseline for your algorithm. Then the algorithm will start from there and will be trained from there on. This speeds up training, of course, and it's a good technique, and I can anticipate you that we are gonna use that. I will use a random agent trained from scratch in episodes coming in the coming weeks, but we will also be training something using imitation learning. it will be fun to understand how it works, because there are few aspects of it that are kind of interesting in the way in which you use human experience, because it can be used in many different ways. Yeah, you're right. You're right. The other thing, the other aspect that you mentioned, yes, of course, you can start from the random trained agent and move from there on. Yes. Now going to the question of Pedro, how many milliseconds? Oh, this is another nice thing. So Pedro is asking how many milliseconds is the latency between enemy action and AI reaction. Well, the system is set now to perform the AI performs one action every 100 milliseconds. So meaning that 10 actions per second. Okay. More or less, and that's the let's say the speed at which the AI works. I have may say try to clear this thing up. It's you don't you need to wait. You know, when the computer performs an action, it is in pause until the AI agent performs its own action. So they are not decoupled. Basically, this means that the game is stopped, the computer performs its own, the AI performs its own, and then they are executed at the same time. And then it goes in this way, iterative way, for entire development of the game. So basically, the speed of the AI agent is more or less 10 Hertz, so meaning 10 actions per second. So far, it can be changed, but so this is more or less the speed of a human in choosing actions, and you will see that actually for this game it is not so important the speed of your actions, because as you will see, good players, actually very good human players, will not use every possible step to throw an action on the game. You know, you will be seeing a lot of empty no actions when a good human player is playing. Ale, your question. No, okay, it's somehow related to this one. For now, there is no, let's say, no handicap, nor on the not on the agent nor on the human. For now, I try to build things so that it's a fair duel between them, and of course, it's a fair duel between, for example, two different AIs, because when it's time to decide the actions on both sides, the game is stopped. The agents select their action, and then the game continues. So in this sense, no handicap, no delay, nothing like that. Curado. Yeah, yes, the point is that okay, I will show you one thing after this this run. Of course, AI algorithms are implemented in GPUs. So they are using CUDA. I was referring to the fact that in real time, when you're playing in this real-time way, so not the speed-up version, in that case, the frequency is about 10 actions per second. But of course, and this is important, and this, Curado, is something that has to deal with what you said, is when they are in training phase, the system is speeded up. First of all, there is no rendering. That itself speeds up the thing about 100%, basically halving the time needed to run, and the system is run at max speed. I will show you a run at max speed with the random agent pretty soon. Now we are at episode 4 of 5, so we have to wait a little longer. Oh, this is a really important note by the Rockerman. The game score, it does depend on the time. It is not taken into account. It is not taken into account now. Of course, this is a nice note. It is not taken into account so far because it's, let's say, I tried to use the standard configuration of the game. So the only thing that is editable is the difficulty. But again, in order to evaluate our agent, we will be using the standard difficulty. Now, Marco, another question. Is an agent trained for game? This is a very, very good question. And this is the so-called, it has a term, a specific term that describes this specific technique. It's called transfer learning, meaning that you learn something in a game and then you transfer that knowledge to another game. This is something that we will be showing, meaning that we, in our plans, we want to share with you also, apart from gaming moment, also coding moments, showing you what's behind the scenes in terms of code, how to implement things. And this is something that will be super nice to see and to share with you. There are a few things that needs to be taken into account. For example, let's say that in game A you have let's say 11 characters, and in game B you have 20 characters. So you will have an input to your agent that is different in size with respect to the input space of the other agent. So you have to be careful in how you use the knowledge of one agent into the other one. I can anticipate another thing. We will be using our agents that are composed by convolutional neural network to process the frame, the pixel frame, and a standard fully connected neural network in parallel, and then they are fused. These latent spaces of the two networks are fused together to choose the action appropriately. Now, since the frame is formatted in the very same thing on every game, reusing the convolutional neural network could speed up really a lot training an agent on a different game. And so this is something that we may be using. Of course, maybe we will show how to implement these kind of things to our viewers. I can anticipate you that I trained one agent on the first game, and I trained another agent on the second game without using knowledge of the first one. Meaning the second game, the agent on the second game has been trained from scratch. Now, another question by Andrea. Oh, nice. Yes, I heard about it, and of course, it's super interesting to see how scripted characters are implemented and can be really difficult to play against with. Now, the key point is we should take really care in understanding if something is unbeatable because it has, let's say, advantages that a human cannot use, meaning if it is reading your RAM values, if it is reading your inputs before they are available to the screen, So in that case, if the game is performing if the game is performing something that is in some sense unfair, if it is performing something that even the best human on the planet cannot do because it's basically not available to our senses, yeah, in that case it's not fair. You know, it's like using God mode in a first-person shooter. And so that's the difference. Yes, it's like cheating, Ale. That's what that is what I was saying. Yes, exactly. Another question by Dom. Oh yes, this is another point, very good point. Dom is asking if why all stages are using the same reward. Shouldn't it be like proportional to the number of the stage, meaning that the further you go, the harder is to beat the player, and that is interesting. Actually, there is one specific variable that tries to take this into account, and it is the stage variable. You see it right here. Now, the stage is something that can be used by the algorithm to understand, okay, now we are in the very first stage, so it should be easy. We are facing an easy opponent, so I can behave in this way. Or in those final stages, the agent may use that to know, oh, okay, now we are in the last stage, so this one should be a little bit trickier than the first one. So in some sense, it tries to catch that thing. But what Dom was, or the point Dom was raising is quite important, because it has to deal with reward engineering. What does it mean? The reward function is the way in which you basically formalize what you want your agent to understand, what you want your agent to optimize. And so being able to create a very good reward function may really speed up training a lot. In some sense, if the reward function is, let's say, composed by many tricky things, it's in some way something that tells you that you, as a human, when programming that function, you are embedding your knowledge. Because, for example, apart from health, you may say, okay, the health, the reward should be negative when you try to hit your opponent and you are really far away from him. Why? Well, because you are wasting your action. You cannot hit him. So why are you trying to use attack actions? Yes, in that way you are telling the agent basically to avoid using actions when too far away. It's in some sense it's a way in which you embed your knowledge. Now, an additional question by Curaro. No, annoying you. Please go ahead with your questions. Oh, super nice. But I don't want to spoil that. The network architecture, I don't want to spoil that, because I will show you all aspects in detail. I will show you the architecture of the network really clearly. I can say, as I said, it's a convolutional neural net, standard elements, plus a parallel fully connected net, and then starting from that fused latent space, we go on towards additional fully connected towards the action. Now I think we are done with the episodes. Another nice question from Erchimau. And that's an important choice. So how did you decide the network architecture? I will answer that. The answer is not so simple. Okay, so now we ended our 5 episodes, and as you can see here, we have 5 rewards. and we have an average of minus 0.09 and a standard deviation that is 0.72. So more or less we can say the random agent has this value here in terms of reward. This is something that we are going to compare with our RL agent, okay? Another baseline, apart from the random agent, is the human player. But before moving to that, I can answer Mao, and the point is that your choice is driven by A, experience in some sense, but mainly by trial and error. That's the problem sometimes. You do have to experiment number of layers, number of neurons, what to place between layers. It's ruled by parameters. These parameters, also called hyperparameters, are typically what needs to be searched among, meaning you have to experiment with different settings and find out which one works better. Okay, so it's not, I mean, there is no recipe for it. You cannot just apply a very simple idea and choose how to, let's say, to select the architecture. Is not so easy for now. Okay, now in my summary and in my, let's say, program, now I had to show the idea to show you another baseline, the human baseline. So me playing against the computer, but we are already live for 1 hour, more than 1 hour, and now, so I don't want this to be too long. So first of all, I would like to share with you the speeded up version of the random agent. Let me just see here. I can just avoid limiting the speed of the game. You already see that it's speeded up, and now you will see that. Pedro, another question. Oh, great one, Pedro. No, you know, that's not a problem at all. Actually, everything is already there. You see now the game is speeded up quite a lot. And so this is the maximum speed for the game. Maximum speed for the game using the rendering. Without rendering, it goes 100% faster, meaning halving the time needed. And so, yes, this is useful, of course, for training. Pedro, your question is interesting. The infrastructure is the very same. You don't need to perform any rewriting. Of course, the problem is that the key point is what you are using as a game manager. Because, you know, you have to have an interface, a layer interface between you in your code and the game. You need to have a library in the middle that basically controls the game, making it advance one frame at a time. So being able to control this, being able to read RAM values, being able to read frames, images. So that's the key point. Now, if you're able to build an interface between your game of choice, an interface that is able to control it, is able to provide you all the information you need, that's it. It can be interfaced with this system, of course, right away, mainly because we are using here a standard version of RL environment. What's the standard version? It's called OpenAI Gym. So the Gym interface is a standard way to take care of RL environments. Now, the only point is that of course with the more difficult is the game, meaning the more different actions you have, the more observation you have. Let's say maybe you apart from the frame, position of characters and health, maybe you have to take into account additional things. Yeah, in that case the other problem is, apart from having the interface, the computational power required to train something. Yeah, that's another problem. Great one, Curaro. Okay, I will. This is another thing that allows me to let you know one specific thing. We are planning, of course, in order to allow everyone who wants to take part in it, in our tournaments, we are planning to release soon our environments. First of all, we are gonna show them and reveal them, all 4 games we interfaced. Then we are gonna release our environments. So in order to allow everyone interested in training their agent and compete in the tournament to see. So Curaro, you are more than welcome to compete in the tournament. I'm not sure I will make my agent compete because, you know, I don't want to you know, beat everyone. Yeah, you know, I don't want to arrive last, okay? So to get the last place, but it will be really fun to have your agent in our system. So now let me stop this because we have seen enough of random agents. I'm really a little bit in doubt if I should use the other baseline, if I have to show you the other baseline. Do you want me to try a few runs myself? Let me know. I warn you, I'm really bad at the game. I don't even know if I'm able to perform a combo, you know. Let me know. Do you want me to run few episodes, me myself? I can try. I mean, I'm not so good, but I'll wait for your someone that Andrea, please explain this one. Mao, let's go. Okay, but no, let's see. I'll try. Okay, let's see. Yeah, but I can do even worse than a random agent, I believe. No, maybe not. Let's see how bad I am at this game. I will choose Ryu too, in order to be a little bit on the same line. Let's see. Welcome. Another interesting aspect. You are so funny. And another interesting aspect is color of the outfit of characters, you know, because okay, that wasn't good. Nah. Because, you know, there are very different colors of outfits, and when you have to train your agent, you have to take care of also of that, because that can vary depending on which button you press when you're starting, and so you need to make sure that your agent sees both, or let's say if there are 2 or more than 2 outfits, in order to be able to train himself with both outfits, so being, you know, immune of different outfits differences. So okay, I won the first round. Yeah, I'm just using one button, you see. Let me try this one. No, I'm not able to do combo. I don't know why. No, there. Okay, that was pretty easy. First stage done. Yay. Okay, now on screen you see things that me as a human I'm using Oh, another great question by Marco. Let me just oh, come on. What's the Hadouken combo? I believe is like down, right and right, I believe, but is not going. I don't know why. Anyway, the problem with the character fighting against itself is a good one. And of course, when you are performing the standard game, that does never happen, at least not in these games. So you are never facing yourself as opponent. And so that can be a problem in some sense. If you are performing a complete let's say training, you do have to take care of that. And so you may use, for example, techniques like self-playing. For example, playing you against yourself on both sides. Self-play is another super interesting technique and basically allows you to compete against yourself in a very, let's say, balanced match that allows you to how can I say, to learn even more, because you are facing the very same opponent. So you're facing someone that has your own skills, and in that sense you are forced to understand, to learn even better every time. Now let me try to catch a combo, because I'm not basically, I don't know the Hadouken, how to do that. Yes, you're right. Actually, I was using another Street Fighter 20 years ago. I was using a Street Fighter 2. So, and maybe, okay, this is another interesting thing. Okay, now where is it? Okay, now the idea of implementing additional games. Oh, that's it. The idea of implementing other games is right there. So if you have like any request in that sense, if you would like to see a specific game, please share the idea with us. It would be super fun. Maybe we will also implement yeah, we will also implement them in live. Okay, that would be really super fun. An additional thing is, if you have feedbacks, if you want to let's say register your agent to fight in our tournament, you can go to the website. I will show that later at the end. You can go to the website and fill the dedicated form, in which you will be able to add your details and your requests, so that we can keep them recorded in our database, and we will take that into account. Oh, come on, this is so bad. I don't know why this is. Oh, it should be avoided. The bonus stage should be avoided in the standard game. I don't know why it happens to be here. Anyway, let's do it. Ha. Done. Okay, I'm still at episode 1. I'm too strong for this level of the computer, maybe. I'm just kidding. Okay, we can stop it right there. So basically this is the idea of what's behind everything. And let's say I will make sure to share with you both baselines levels, random agent baseline and human agent baseline. In that way, we will be able to compare our trained agent against those baselines, and it will be really meaningful to understand how better the agent was with respect to the pure random one. Now, final words. Let me say that again, what I was saying is in the website, you can take a look here on the bottom part. If you want to train your agent and compete, you can fill this form here. You see, specifying here what do you want to do, if you want to collaborate, if you want to train your own agent, and so on and so forth. And of course, in order to have the feedback, you can get in touch with this other form here. So the feedback about what you saw, the idea, and so on. So I believe we are more or less done for today. I mean, take a few other questions if you have. Otherwise, we will be live online next week on Tuesday and Thursday, same time, 10 p.m. Italian time. And so I would love to have you again here to exchange a few words. We will be revealing the third interesting game. So I cannot say anything more than really thank you for being here. It was really fun exchanging few words and also discussing super interesting aspects. We will take a look at all those things that you mentioned in the chat, super things. Thank you, Curara, for your words. Dom is saying that Tuesday and Thursday are selected because the other days are more or less busy with the gym. Actually, unfortunately, in those days before COVID, that was the case. Now we are forced to do what we can at home, you know. But of course, Tuesday and Thursday, please, if you want, I will be here. For now, thank you, Mao, for your words, and thank you, guys. Super great viewers today, and I wish you all a good night. Take care, and really looking forward to seeing you next time. Oh yes, Pedro, I know that. I know that. That will be a problem maybe, because on Tuesdays, you know, there is the Champions League. But I understand. You can watch me in background. That's not a problem. Yes, also a human being needs to be trained. You're right. You're right. Thank you guys again. It was super fun. Okay. Bye guys. See you next time.